Ryan, what worked and what didn't work in the competition and why?
All right. So for 3 of the 4 rounds, our drivetrain worked, perfectly. These new wheels that utilize these like couplings with these nuts and bolts seem to work a lot better than our previous, just friction fits. Our sheep mechanism, for the most part, seemed to work very well. Our first go around, we only got 2 sheep in because we think some of the code had issues. However, the next time we got all 4 sheep in, and the last time we got 3 sheep in. I'll play a video real quick of 3 sheep going in.
So here's the 3 sheep. Yep.
And the main thing we learned is that this switch needs to be moved back so we don't rotate with the track, which you'll see in a minute. And we also need to move it up a bit so we don't get caught on other sheep. So as you'll see, we accidentally shoot a sheep into we get caught on a sheep that's already in there, and we shoot 2 sheep in the same section.
As you saw at the start of the video too, this whole machine, the Terrible Terror, shifted to the left. And that's why we need to move this switch slightly back and slightly up.
Yeah. And luckily for us, one person knocked out the duplicate sheep we had in that section. But in the future, it's definitely something we worry about.
And then what about this other video? Does that show us anything else?
Which?
Oh, you click on the top left here.
There.
Okay.
Okay.
So this is the one with 2 sheep?
Yeah, this is the one with 2 sheep. Basically, we had to adjust the code because when you saw when it rotated with it, because it was too long, it activated twice. And the code has a system so it can only activate 4 times total. And it activated twice in a really short time span, so we weren't able to get all the sheep in because it activated twice but only sent 1 sheep.
All right. Thanks, Ryan. Hey, Colin. What do you think we should be working on next? And what changes have been made? And what changes are we going to make and why?
Okay, so changes that were made. Again, this is now coupled instead of a friction fit. This was 3D printed to save weight. And then there's this little structure for the piston was redesigned a bit to save space.
Yeah.
Now, what needs to be changed immediately, this little 3D print to go on here to shift the switch up and back is pretty much the only thing left to do on the sheep. For the drivetrain, I think we're good. We occasionally have to come in and screw the nuts back down, but that's as good as it's going to get, we think. For the switch, for this lever arm, the main issue is with this rack and pinion down here. So the rack has never been quite straight, right? And as you can see with the gear, it's being chewed up pretty bad by repeated use. So we need to come up with a better thing than MDF for the gear. It's probably going to be 3D print, and we're probably going to take a second rack and add it on.
Yeah, maybe PLA with a few extra wall loops, something
just to
like
toughen
that.
up to toughen up the gear so that the teeth stop falling apart. We also need to, if you come back here, this can move around, which we don't want. So we need to remake this mount for the motor, and then we also need probably to 3D print it here, because what we've run into is trying to manufacture the correct height for the wood is just very difficult.
Yeah, getting that rack and that pinion to line up with each other has been a very difficult task for us. So we need some find way to a way to do that consistently.
Yeah. We also need to come up with a little better system for the wires.
The wire management.
Yeah.
Yeah, we have some tape here, but we had some plans. You went to Home Depot, right?
Yeah, we have what's it called? We have, where is it? These things. These are cable clamps. Yeah, we have cable clamps. So we can, at least for this tubing, nail it down, and then we can probably also take bundles of wires and put it in other clamps and then nail them down too.
Cool.
So that's our current plan for wire management.
And Peyton, can you tell me a little bit about the torches and the eels and what are our plans there?
I'm so glad you asked. So I was actually just thinking about those. So initially we had planned to do the torches this sprint things didn't work out super well.
Why didn't they work out super well?
They didn't work out super well because it kind of relied on us getting this scissor lift working, because basically you had two arms right here, and they would be connected to this screw that was connected to a block right here that was also connected to this bit. And basically, as this raised, the screw would release, which would let the two arms fall down.
Knocking the torches onto the
Exactly.
whatever it's
Onto
called.
the
The
target.
circles. The target.
Yeah, the target. And in fact, we actually got it with great accuracy, but there was a lot of power to it that we had to work out. We have an interesting sponge strat that you may have heard of to help with that, where we just have a sponge right here that hits the torches as they fly and kind of dampens the energy.
What about these fish and eels?
Fish and eel. I was just thinking there. So as you can see right now, we're pretty short on space, which is going to be a limiting factor here. One idea we have is to first change the way the sheep are set up so that there's room down here that we can put the tank, and that'll give us this whole area to have something for fish and eels. So we'll have these little arms that shoot out onto the rotating track, and that's how we'll collect everything. Again, depending on how much space we have, we might try to have a system that only collects the fish, so that way we don't have to worry about relocating the eels and separating them, which takes up more space. And yeah, that's kind of just that.
And then for as far as like difficulties and future plans, we foresee a lot of difficulties, especially with this report coming up. We have 1 week to get the report and the presentation done. So we're gonna try to focus on that. It's the largest part of our grade, but with only 2 weeks till the next sprint, time seems like our biggest constraint, as well as material. We don't know what we're gonna use to sort of get this rack in place here. Same with this gear, so we have to find some reliable materials. Getting stuff shipped in takes time. So I think time's our biggest concern right now, trying to figure out where we're gonna put things, when we're gonna do things, and who's gonna work on what. Some of those time management things we've thought of is sort of breaking up, okay, who's gonna come in the lab and work on stuff in person, and who's going to take care of the documentation, who's gonna work on the project, and kind of flip-flop there. Because another thing we learned was having like 4 people try to work on one robot all at once is just impossible. You can only get really 2 people working on this at a time, and any more than that, and it's just too many cooks in the kitchen. You can't get anything done.
Okay.
And I think that sums up our plan for the future.
Okay.
Yes.